Here's what you need to know about what is a router. This is an exam topic in Domain 2, Network Infrastructure. By the end of this video, you'll understand the core concepts and exactly what to expect on the CompTIA Network Plus exam. Let's get into it. A router connects multiple networks and forwards packets between them using IP addresses. It operates at layer 3 of the OSI model and uses a routing table to determine the best path for each packet. Routers also separate broadcast domains and serve as the default gateway for devices on a local network. Key concept: Layer 3, packet forwarding. Routers forward packets based on destination IP addresses, not MAC addresses. Each router interface connects to a different network. The routing table maps destination networks to the best outgoing interface. Routers consult this table for every packet they receive. Key concept: routing tables. The routing table holds routes learned statically, manually configured, or dynamically via protocols like OSPF, eGRP, or BGP. When a packet arrives, the router matches the destination IP to the longest matching prefix. If no match exists, it uses the default route, or drops the packet. Key concept: default gateway. Every end device needs a default gateway, the IP address of the router interface on its local subnet. When a device sends traffic to a remote network, it forwards the packet to its default gateway first. The router handles all further routing decisions from there. Key concept: broadcast domain boundary. Routers block broadcast traffic by default. Each router interface creates a separate broadcast domain. This prevents broadcasts from flooding the entire network, a critical function in large enterprise environments where uncontrolled broadcast storms can consume all bandwidth. Let's look at the full breakdown. OSI layer, router, layer 3, network, switch, layer 2, data link, hub, layer 1, physical. Addresses used, router, IP addresses, switch, MAC addresses, hub, none, signal only. Broadcast domains, router separates, one per interface. Switch does not separate. Hub does not separate. Collision domains, router separates, one per interface. Switch separates, one per port. Hub, one shared domain. Here's a real-world example. A home router connects the local network, 192.168, 1.0/24, to the internet. When a laptop sends a request to a remote server, it forwards the packet to the router's LAN interface, the default gateway at 192.168.1.1. The router checks its routing table, matches the destination to its WAN interface, and forwards the packet to the ISP. Two completely different networks communicate seamlessly. Quick recap before you go. 1. Routers forward packets between networks using IP addresses at layer 3. 2. The routing table maps destination networks to the best outgoing interface. 3. Static routes are manually configured. Dynamic routes use OSPF, eGRP, or BGP. 4. Every device needs a default gateway, the router IP on its local subnet. 5. Routers separate broadcast domains, one broadcast domain per router interface. That's what is a router covered. Exam tip: remember the OSI layer lineup. Routers =sign layer 3, IP addresses. Switches =sign layer 2, MAC addresses. Hubs =sign layer 1, signals only. Routers separate both collision and broadcast domains. Switches only separate collision domains unless VLANs are configured. Next up, what is a switch? If this helped, hit subscribe. New topics drop every week.